dirt modifieds are one of the most popular classes in all of oval track racing. The cars are more affordable than in many other classes, the fields are full, and the racing is tight with lots of passing. Oh, and the engines make a ton of power for the relatively light cars. That never hurts. So today we're back in Terre Haute, Indiana at the Motorsports Unlimited shops where owner Lance Stillwell is building a new big inch bullet for dirt modified racer Tanner Reed. Stillwell has already built a race engine for Reed that does well on the smaller tracks, and this one will have more cubic inches and should be a beast on the larger tracks that Reed's team visits. But building a dirt oval race engine that's capable of winning races can be a tricky task. There's a lot more to it than just developing peak power. Dirt motors have to pull hard across a wide RPM range, so it needs great acceleration from the moment the driver exits the turn at low RPMs and begins applying pressure to the fun pedal all the way to the end of the straights when he or she may have the engine pegged at 7,000 RPM or more. Here's how Stillwell explains his philosophy for building these engines.
Well, this one actually is a 418 cubic inch for dirt modified, UMP dirt modified in the local area. It's kind of a common engine we do around here. But the main challenges of this is it's not necessarily like a drag race application where it's a wide open. We kind of got to set the whole combination up for a broad torque curve and make the engine drivable so the driver can actually manage it out of the corner and still maintains down the straightaway. And that's a little bit of development in camshaft area and a good induction system. But those are kind of the main challenges. And it's got to live. You know, this thing needs to live several nights for the customer to get the use out of it. So,
this is actually the second build we've done with Stillwell and Motorsports Unlimited. The first time around, we built a 1,000+ horsepower big block for mud bottom. Another great American sport if you ask me. If you'd like to check out that build, I'll put a link to that video in the description below. For this build, Stillwell starts with a forged crank from PBM Performance Products. The crank has a 3.875 inch stroke, and all the counterweights are knife edge to help cut down on power robbing windage. This is a precision piece designed for engines making tons of power, with large chamfers on all the radiuses on the cheeks of the journals. It's also been heat treated and nitrided for strength, and all the journals have been micro polished. Lightning holes on all the rod arms also help lighten the crank to 49 pounds. Motorsports Unlimited has a strong working relationship with PBM Performance Products and their associated brands. So you're going to see many of their products in this build. This includes the PBM forged connecting rods. Stillwell says this has helped keep costs down so that he can give Reed Racing much more motor than the team could have afforded otherwise. But anyhow, back to the connecting rods. The forged H-beam rods are 6 inches long and forged from 4340 steel for strength. There's also high-end ARP 2000 bolts in the ribbed cap. Notice how the underside of the big end, where the rod bolt goes through, is machined back to create extra clearance for stroker applications. And of course, the pin end is bushed with silicon bronze to accept a low-friction floating wrist pin. Once everything has been checked over and cleaned, Stillwell outfits the rods with Cleveite coated H-series bearings. Stillwell says that this is an engine build constrained by real-world costs. So even though it should be capable of winning on any night it's out there, it isn't exactly over the top with exotic or super expensive components. Going on to the connecting rods will be a set of forged JE pistons. These are actually shelf stock pistons, but they are incredibly nice. The pistons have a relatively light slipper skirt design. The entire bob weight for the piston and connecting rod is 1,716 grams. The skirts have been given an anti-friction coating to help keep from scuffing the cylinder bores if the oil pickup ever gets uncovered. Lateral gas ports will capture expanding combustion gases and route them behind the top ring to help provide a better seal against the cylinder bore. The compression distance is 1.062 inches, and there's also a nice combo valve pocket and 10.8 cc dome to help kick the compression ratio up a bit for more power. We kind of got ahead of ourselves there. All that rotating assembly has to have a block to go into, so I guess we need to cover that. The rules for the UMP A-Mod class require a cast iron V8 block and wet sump oiling, so Stillwell chose a Motown 2 iron block from World Products. The block has a Chevy standard 9.025 inch deck with a 4 inch 145 thousandths bore. Combined with the 3/8 750 stroke, we get 418 cubic inches of power. Extra thick walls mean the bores are Siamese, and the oiling system gives priority to the main bearings. That's critical for extended high RPM blasts, which is exactly what oval track racing is all about. There's also a big cam tunnel to accommodate a large 50mm camshaft. The bigger cam is to ensure that it doesn't twist at a high RPM, even with extra strong valve springs installed in the cylinder heads. No twist means proper valve timing in all 8 cylinders. To make sure that the extra large camshaft doesn't bash into the connecting rods, the cam tunnel has been raised 134 thousandths of an inch. There are also roller cam bearings installed in the block. The roller bearings free up a few horsepower, but the real reason that they're there is they can withstand greater loading from heavy valve springs than a conventional Babbitt cam bearing. In the lifter valley, the Motown 2 block comes with bronze lifter bushings. Down below, billet steel 4-bolt main caps can help provide extra rigidity. Like the rod bearings, the mains are dressed with Cleveite coated H bearings. The H designation means that they're designed for high-performance engines with a steel backing, a harder overlay, and more clearance for a larger crank fillet. After determining the bearing clearances are correct, Stillwell preps the block for dropping in the crank. Notice this custom-made tool for popping off the main caps. But before Stillwell can actually start assembling the engine, he still has one more check to make. He runs the Urson solid roller cam he chose for this build through a cam analyzer to ensure that the specs on every lobe are as exactly as they should be. Stillwell has put a lot of development work with the cam specialist at Urson to pick the best possible cam for this application. So we'll respect his desire to keep the specs to himself. But we are allowed to share that this is an LS style firing order with a 7.4 and a 3.2 cylinder swap. We can't tell you anything about duration and lobe separation, but we can tell you that net valve lift will be in the range of 600 thousandths of an inch. Because this is a solid roller, and also because it will be spinning inside roller bearings, this cam is cut from billet steel. But it has a pressed on iron distributor gear, so it can work with a standard iron gear that comes on most distributors. With the camshaft in place, Stillwell turns his attention to installing the crank. Main studs provide a better clamping lobe for the billet main caps than bolts do, and the large ring dowels the Motown 2 block uses ensures the caps can't shift in their registers. The inner 3 caps use splayed outers, so bolts are used to ease assembly. Both the inner studs and the outer bolts are sized at 7/16, so everything gets torqued to 75 foot-pounds. Stillwell assembles the JE pistons onto the PBM connecting rods. He prefers to apply the assembly lube directly to the pin bores with a brush to ensure that the lubricant stays exactly where it needs to be. Wire locks hold the piston's wrist pins in place. Squeezing 375 thousandths extra stroke into the block along with a 6-inch connecting rod means that the pistons have to use a compact 1.062 inch compression height. That's fine, but it does put the wrist pin bore into the oil ringland, so a support rail is used to keep the oil ring assembly from flexing. The rings, by the way, are sized at 0.43, 0.43, and 3 millimeters. and the top rings are gapped at 25 thousandths, while the Napier second rings have a slightly larger gap at 27 thousandths. More assembly lube is applied directly to the rod journals, and the piston and rod assemblies are dropped into place. The ARP rod bolts are 1.5 inches long, so Stillwell confirms the correct torque required to achieve 5 thousandths of an inch of stretch, and then pulls all the rod bolts to 72 pounds with extreme pressure lube on the threads. Another feature of the Motown block is that it can handle a stroke of up to 4 inches right out of the box. These notches on the oil pan rail make fitting the 3.875 inch stroke we're running a piece of cake. After degreeing in the cam, Stillwell buttons up the front end and then turns his attention to the oiling system. This is one of Champ Pan's professional series oil pans designed for maximum performance in a wet sump application. The oil pan gasket is a one-piece design, and the oil pump is a high-volume unit for Melling. The attached pickup came from Champ to go specifically with this oil pan. One of the ways this pan helps conserve power is by pulling the walls on the right side of the pan as far outward as possible. That creates more space for oil to sling off the crankshaft without the chance that it's going to bounce right back onto the crank and create power-robbing windage. But the oil pan bolts for the block are still in the same location, and that makes for an interesting arrangement. There are actually 3 holes in the bottom of the pan that allows Stillwell to reach through the interior of the pan and get 3 bolts in place along the right side of the pan rail, which is enough to get a good seal. The key is to maintain control of the bolt and not let it drop into the crankcase and then decide to play hide and seek with you. You can do this by putting some grease in the socket, which helps keep the bolt stuck in there until you can get it threaded into the pan rail on the block. Once the pan is bolted down, there are 3 threaded plugs that seal the bottom of the pan. They're all O-ring to ensure the pan doesn't leak, and once they're in place, a set of C-clips fit in the grooves so that none of the plugs can back out. Now we can return our attention to the top of the block. The World Products block has oil galleries to the lifters and valve train that run through the valley. That creates an easy way to actually tune the oil flowing through the engine. When you have solid roller lifters and roller rocker arms like we'll be using, the oil requirements to the top of the engine are significantly reduced. So Stillwell installs 1/8 inch steel pipe plugs that have a 51 thousandths inch hole drilled in them to act as restrictors for the oil flowing to the top of the engine. Then a 1/4 inch pipe plug goes into the top of that hole to seal everything off. This arrangement should help free up additional power by limiting the amount of oil that drains back down through the engine and past the crankshaft where it can create windage. The lifters are a set of tie-bar solid rollers from Morrell. Stillwell covers them in assembly lube, then after they're in their bores, pours break-in oil directly over them to make sure they are completely saturated. For the break-in and dyno pulls, we'll be using Driven Racing Oil's conventional 15W50 break-in oil. The cylinder heads will be sealed to the block with a set of Cometic multi-layer steel gaskets with a 40 thousandths compressed thickness. Once they're in place, Stillwell threads in the ARP head studs until they are gently bottomed out in their blind holes. And now we're ready for the cylinder heads. Stillwell went with Profiler's 23-degree aluminum cylinder heads. The heads are CNC cut with 68 cc chambers. Combined with the longer stroke and dome pistons, that brings the compression ratio up to a little bit over 14:1. The intake runners are designed for high RPM, big inch applications with a volume of 235 cc's. They feed air and fuel past 2 1/8 inch diameter intake valves and 1 inch 600 exhausts. Both are from Urson and both have an 11/32 inch stem. Because this engine will have to live at least a season of hard racing between rebuilds, the valve seats are kept at the standard 45 degrees. Some gains might be able to be found with steeper valve seat angles, but steeper seat angles also wear more quickly. The valve springs chosen are from Urson's FSP Professional series. They are a nested spring with an OD of 1 inch 580 thousandths and a spring rate of 536 pounds per inch. Urson says they use an ultra clean wire with virtually no inclusions so that these springs can work well in high RPM endurance applications like oval track racing. Stillwell preferred to keep the installed height to himself, but we do know that these springs can be compressed to 1 inch 170 before reaching coil bind. They're held in place with a set of Urson titanium retainers to help keep the valve train mass as light as possible. Anyhow, while we've been geeking out over the valve and the spring specs, Stillwell has been securing the heads to the block. The nuts on the ARP studs are all torqued to 80 pounds. A shaft mount rocker system from T&D will help make the most stable valve train possible. The key is to make sure that the rocker arms are at the correct height relative to the top of the valve stems. This tool helps with that. Once the shoulder can sit on the rocker shaft while the rest of the tool is parallel to the valve stem, you know you have the correct height. If necessary, the height can be easily adjusted by adding or removing shims underneath the steel rocker stand. Once Stillwell has the height of the stand dialed in, the rocker stand bolts are torqued down to 50 pounds. The push rods can't go on if the rocker arms are already in place, so they have to go next. Stillwell applies a little extreme pressure lube to both ends of the 7 3/4 inch push rods from Urson. These are 5/16 diameter sticks with a wall thickness of 105 thousandths of an inch. Now the aluminum T&D rocker arms can be bolted up. Each pair of rocker arms mounts on their own 4130 case hardened steel shaft, and the shaft is bolted to the rocker stand with 3 fasteners for maximum stability. Those bolts are torqued to 23 foot-pounds. This T&D rocker set has been designed specifically for these profiler cylinder heads. Notice the intake rockers are offset 375 thousandths to straighten up the push rods and make room for the high-flowing intake ports. It's a bit harder to see, but the exhausts are also offset 80 thousandths. For an intake manifold, Stillwell chose a World Products Motown cast single plane aluminum intake. The single plane, of course, tends to move power higher in an engine's RPM range. To make the most of this manifold, it's been hand ported to open up the plenum a bit and to match the intake runners on the profiler cylinder heads. Stillwell says the World Products intake is capable of flowing plenty of air right out of the box and only improves with a little handwork. Oval track valve covers vent on only the left side of the engine because centrifugal forces on the racetrack would try to push too much oil out of the vent if any were on the right-hand side valve covers. For the ignition, we're using an MSD Pro Billet distributor with the mechanical advance locked out. But Stillwell has a good tip for anyone building dirt track engines or really any engines that will be living in a harsh environment. He sprays the reluctor wheel with a light coat of paint before reassembly. The paint isn't thick enough to interfere with the magnetic pickup's ability to see the legs of the reluctor wheel as they spin past, but it will keep the steel reluctor from rusting, which can cause big problems with the ignition down the line. From prior experience, Stillwell already knows that these engines respond well to a carb spacer to create just a bit more plenum volume. To achieve that while also maintaining good signal at the carburetor, he uses a 2-inch tapered spacer cut from aluminum by High Velocity heads. And so we are finally ready to go to the dyno. As I already mentioned, this engine will be burning methanol. The dyno headers are a set of mild steel Schoenfelds with 1 7/8 primaries and 2-inch secondaries. The carburetor is a custom build by Willys Carburetor and Dyno Shop. The Willys carbs have unique externally adjustable metering blocks that allow jet changes without disassembling the carburetor. This is the 750 CFM size carb. Now that may seem a little bit small for a high RPM 418 cubic inch race motor, but remember, throttle response and drivability is just as critical as peak horsepower when it comes to being competitive and winning dirt oval track races. Stillwell and his crew ran a break-in on the engine, checked over ignition timing, valve lash, and fuel, and we're ready to finally do what we really came for, make some dyno pulls in anger. On the dyno, this alcohol burning small block showed great results. Stillwell pulled from 3,500 RPM through 6,800. Peak power came at 6,500, but power levels hadn't fallen off as much as 20 horsepower at 68. So the team should be able to gear their car to play on both sides of the power peak on the track so that they can achieve the fastest possible lap times. But meanwhile, the peaks are still good to know. This 418 made 619 foot-pounds of torque at 5,600 RPM and 705.5 horsepower at 6,500. But Stillwell thought he could still squeeze out just a little more power. Simply going to a larger carb would likely help power, but at the expense of good throttle response. So Stillwell pulled a wily veteran's trick. He kept the carburetor 750 CFM main body, but swapped in a base plate for an 850 carb. And now look what happens. With just that little change, peak torque improved by 5.7 foot-pounds to 624.8, and horsepower jumped 7.4 to 713. And it wasn't just the peaks that improved, as you can see. Power improved throughout the run with averages of 580.9 foot-pounds of torque and 572.5 horsepower throughout the run. That should be more than enough to help push Reed Racing's Dirt Modified to the front and keep it there. Hey, thanks for watching.